and it is impacted on the lunar surface, and moon surface actually tracking the solar winds. So these H plus ions are actually the source of water, which actually H plus, which is reacting with the minerals in the moon surface or moon sand or moon oil, that is called regolith, and it is forming water or hydroxyl molecules. Second thing, the water is getting delivered to the moon to asteroids and comets. So asteroids, there are carbonaceous conglomerates are there, so they are having good amount of quantity of water. This water is getting delivered to this asteroid and comets. Third thing, that the individual resources, it's the volcanism. So whatever volcanism is happening on the moon, yes, it was thought that volcanism, because of the volcanism, it was a dry volcano. So moon mantle was dry, so that's why there is no coming out of hydrogen bearing or H2O from the volcanism. But latter part, people from the intact sample, the Apollo missions, people found that the glasses, there are water intrusions. So from that it was found that in the mantles also, mantle is not dry, it's a wet mantle. And this volcanism is playing a very critical role in having water in the moon. Now we have water. How this water is getting transported and where? So if the water is coming from the extraterrestrial sources like exogenous sources of comets and asteroids, then this water actually getting transported to the shadowed parts of the moon. Why? Because of the thermal gradient. The illuminated part, because of the solar beam, this water getting dissociated. So their water cannot become preserved. So this water is getting transported by hopping mechanisms. The shadowed regions where they can be preserved. Secondly, the water is getting transferred to a transient atmosphere. When the volcanism is happening, so during the volcanism, you won't know that it's the airless body, it won't have any atmosphere. But during the volcanic period, it is having a thin atmosphere on the moon surface, that is called transient atmosphere. Because of the released gases from the volcanoes, and this atmosphere actually helping to deliver the water from the volcanic outgases of polar region. So polar region is cold, so there water is going further to the atmosphere and trapped. Now, what kind of water we can expect on the moon surface? So, moon is having majorly three kind of water. First is in the lattices of the molecules. Whatever molecules are present in the liquid or soil elements are present, minerals are present, it is in the dot H2 format. So in the geology that there are lots of minerals which are having dot H2 or dot OH. So it is in the lattice of the molecule. Secondly, we are getting water in the vesicles. So whatever volcanism is happening, so volcanism is having four spaces. So volcanoes pores, that is called vesicles. So there water is getting trapped over the millimeter or nanometer scale. But whatever water is depositing from the transient atmosphere, the surface or subsurface, it is making a thick good amount of ice layers in the subsurface or in the surface. So majorly three kind of water. One is in the trapped in the lattice, one is in the vesicles, and third is the ice layers, the surface or subsurface. So this is the theoretical understanding. So to understand whether that is happening or not, we did multiple simulations of the geological scenery over here, and people find in the polar regions of the moon, majorly that can have a thick ice deposits, the subsurface. In the surface from up to 10 meter, there can be a gardened ice. Gardened ice means small particles of ice distributed here and there randomly on the soil. And in the subsurface beyond 10 meter, you can have a thick ice deposits. So these are the in the right hand side in the table you can see different craters, impact craters, the name of Howard crater, Nansen crater. These are the name of the different craters present on the polar regions of the moon. They can have an ice of around 295-meter thick the subsurface. So you can understand how thick ice will be present in the moon. Now, if ice is present or water is present, how we can detect or how? So already there are lots of instruments has been sent to lunar orbit to find or to sense the or to detect the presence of water or ice in the moon surface. Like UV spectrometer, IS spectrometer, neutron spectrometer, radar, laser, all these instruments have the capacity to understand different component of ice. Say for example, IS spectrometer is sensitive to the OH and H2O molecule, whereas neutron spectrometer is sensitive to the hydrogen. Radar is sensitive to the different ice particles present in the surface of subsurface, as well as laser is sensitive to the frost, surface frost present on the moon. And also they are having different depth sensitivity. So if you see the UV spectrometer and IS spectrometer as well as laser, they are sensitive to the top surface of the moon. Whereas if you see the neutron spectrometer or radars, up to certain extent of the depth, they are sensitive. Say for example, neutron spectrometer is sensitive to 1 meter depth, radar is sensitive to the 5 meter of depth. Now what it found. So this is first or most important example which shows that the presence of ice or presence of water on the moon. So this is from the Chandrayaan 1 MQ radar. This is the IR spectrometer or spectrometer. So from this sensor, it will discover presence of H molecule or H2 molecule, the polar regions of the moon. So the two parts in the right hand